Good morning, students. I'm going to start the electrostatic chapter. I'm going to explain the so charge particle is projected perpendicular to the electric field. Now I'm going to start the topic. Now we'll see okay here. So charge particle particle is projected to perpendicular to projected perpendicular to electric field. Charge particle is projected perpendicular to the electric field. Now you will see direction of electric field is this is the direction of electric. This is the direction of electric field. Now you will take this is a plate, this is a positive plate, this is a negative plate. Direction of electric field is from positive to negative. Now this is a positive charge. Positive charge is projected with a velocity v. Charge particle is projected with a velocity v perpendicular to the field. Now the charge is positive charge is entering into the field. The charge this is a positive charge moves with a velocity v. The charge tries to go straight. The charge tries to go straight, but this is a positive plate, this is a negative plate. This is a positive charge. This is a direction of electric field. Direction of force is charge is downward direction. Positive plate, negative plate. Positive plate will repel to positive charge is this direction. Now you will see this is a position of the charge. Here this is a Vy. At this position of the charge particle, speed is Vx. Now this is V, velocity of the charge particle. Here make an angle alpha. Once again, positive plate, negative plate, direction of electric field from positive to negative. Charge particle is projected with a velocity v perpendicular to the field. Now charge entering to the field, the charge goes in this path. So what is the reason? Means this is a positive plate. This positive plate repel to positive charge is downward direction. This is a negative plate. Negative plate will attract positive charges downward direction. Now, path traveled by the charge particle is parabola shape. Parabola shape. Now, this is after t time. This is the position of the charge particle. Charge particle. Now, you will see in x direction, y direction. X direction, y direction. This is a x direction, x axis. This is of y axis. I'm taking. In x direction, so ux is equal to ux. So this is a charge is projected with a velocity u. Velocity u initially. Charge is projected with a velocity u with a uniform velocity. Uniform velocity. Next a is equal to 0. Acceleration to gravity. Acceleration is 0. The charge moves with a velocity. The charge is moves with a uniform velocity along a x-axis. Along a x-axis. Acceleration is 0. Next, after t time, what is the velocity? What is the velocity of the charge particle? V is equal to u plus at. Now v is equal to u. Vx means this is the x-axis. Now Vx is equal to Vx means u. A means 0 t, and Vx is equal to u. And final velocity also Vx is equal to u. In y-axis, so this is a freely falling body. This is a uy is equal to, at this position, the body, freely falling body we are at this position. Body is projected with a velocity u along the x-axis. The body is not a projected in a y-axis. Now at this point, velocity of the charge particle is freely falling. Now uy is equal to 0. Uy is equal to 0. But the acceleration a is equal to, acceleration means charge particle moving this direction. Acceleration means eq by f. Eq by f. That is the acceleration of the charge particle. Now after t time, what is the velocity of the charge particle? Now you will see. Vy is equal to uy means 0, a means eq by m into t. This is a Vy is equal to eq by m into t. This is a velocity of charge particle in y direction. This is a velocity of the particle in a velocity of the charge particle in x direction. Charge particle moving in a x-axis is uniform velocity. Charge particle moves in a y-axis is eq t by m. Next, how much distance traveled by the charge particle in x-axis, y-axis? How much distance traveled by a charge particle in xy axis. Now you will see x-axis, y-axis, distance and travel. Now s is equal to ut plus of it square. I am taking of it square. I am taking of it. S means distance in which direction? X-axis. U means ux x-axis. I'm taking this is Sx means x-axis. Uxt means I'm taking ux. Now I'm taking plus this is acceleration is along x-axis is 0. X is equal to ut. X is equal to conditions. What is the conditions? I'm going to write the condition. You see the conditions in x-axis. In x-axis condition is what is the condition? Ux is equal to u, ax is equal to 0. S means displacement means x. Next, s is equal to ut plus of a square. I'm going to write of a square. S means x-axis. Xx, ux, ax. Now I'm right. Ux means u, t means t plus of a means 0 t square. 0 t square. Next, x is equal to ut. That is your value. Now in y-axis, assume since uy is equal to 0, a is equal to ay is equal to eq by m. Next, s is equal to ut plus of at square. Ut plus of at square. S means sy, uy, ay. Sy means what axis? Y axis. Uy means freely falling 0 t plus of ay means e cube by m t square. Now y is equal to 0 into t means 0. 1 by 2 e cube by m t square. Now in this equation, t is equal to x by u, x by u. So y is equal to 1 by 2 e cube by m. T means x by u whole square. Y is equal to 1 by 2 e cube by m, x square u square, x square u square. Now you will see this is a, I'm taking this is a k, this is a y is equal to k x square, y is equal to k x square, k is equal to e cube by 2 mu square, mu square, k is equal to u square. This is a parabola path, parabola, parabola. Path is, particular path is parabola. Charge particle is projected perpendicular to the electric field. Electric charge particle is projected to electric field. This is a positive plate, negative plate. Direction of electric field is from positive to negative. Positive to negative. The charge charge is projected with a velocity u perpendicular to the field. Now charge enter into the field. The charge try to goes this direction, and path traveled by the charge particle is parabola shape. Parabola shape. Positive plate, negative plate. This positive, this negative charge plate will attract negative charges downward direction. Try to bend like this, like this. Now this is actually this is I'm going to write this is axis. You see x-axis, x dash, y dash axis. Now we will see a path traveled with the charge particle is xy plane, xy plane, xy plane. This can be resolved into two components. One is vx, vy components. Velocity of the charge particle can be resolved into two components. One is vx, vy. This is a making angle of force. Now this is a we call this is a freely falling. This is a charge moves with a uniform velocity. Charge is moves with a q is moves with a uniform velocity along x-axis. So freely falling charge is freely falling along y-axis, along y-axis, along y-axis. Now I'm taking x-axis, y-axis. This is after t time velocity gain after t time. This is a velocity gain after t time in y-axis. This is a velocity gain of t seconds in the x-axis. This is a velocity gain, velocity of the charge particle gain after t seconds in a y-axis, But in x-axis, ux is equal to u, acceleration of the charge particle is 0. Vx is equal to u plus at. Vx is equal to ux means u plus acceleration is 0. Vx is equal to u. In a y-axis, uy is equal to 0, a is equal to eq by m, vy is equal to uy plus at, vy is equal to 0, eqt by m, vy is equal to eqt by m. That is equation. Now you can take v is equal to root of vx square plus vy square. Also you cannot. Otherwise you need tan alpha is equal to vy by vx, vy by vx. We can take this. How much distance traveled by the charge particle in the xy axis? Xy axis. How much distance traveled? This is Distance traveled by the charge particle in the t time. Distance in a t seconds. How much distance? How much distance traveled by the charge particle in the xy axis in a t second? In a t seconds. This is distance traveled by the charge particle in a t seconds. S is equal to ut plus of this. The ux is equal to u. Acceleration of the charge particle is 0. S is equal to x. All values put in this equation. Now x is equal to ut, t is equal to xy. Next, this is also distance traveled by the charge particle in a y-axis in a t seconds. S is equal to ut plus half it square. Uy is equal to 0. A is equal to u cube by m. Now all values put in this equation, we are getting this equation. This equation. T means in t is equal to x by u. This value put this equation, we are getting this one. We call y is equal to k square. K is equal to e cube by 2m square. E cube by 2m square. Y is equal to kx square means there is a parabola equation. Path to travel with the charge particle is a parabola path. Parabola shape. Parabola shape. This is the equation. Next class. Next one. Next example problem. This is a spring. One end is connected here, another end is connected to mass m. This mass having positive charge. Direction of electric field is this direction. Direction of electric field is this. Now find the example problem. Find the equilibrium and maximum extension of spring when the electric field is switched on. Switch on. That is a problem. Now find the equilibrium and maximum extension of the spring when the electric field is switched on. Electric field is switched on. Now you will see the diagram. This is a spring. One end is connected to this body, another end is connected to black body. The mass m is charge is positive charge. Direction of electric field is from this is a direction of electric field. Now you will see this is a positive plate, this is a negative plate. Direction of electric field is from positive to negative. This is a positive charge. Direction of force is this positive plate repel to this positive charge is this direction. This negative charge also attract. This is a charge is this direction. Force of charge is for faster charge basic point. points. For positive charge, direction of electric field and the force both are similar. Negative charge, electric field and opposite to the direction of electric field and force both are in opposite direction. For positive charge, direction of electric field, direction of force both are parallel. Both are parallel. This is a positive charge. This is a positive charge. This is a positive charge. Positive charge. This is a positive negative plate. This positive plate repel to discharges this direction. The spring expands. This is a positive plate. Repel to discharges this direction. The spring expands. Negative charge also will attract to positive charge this direction. Spring expand. Spring expand. Now, initially, I'm taking this is for example, equilibrium position. Equilibrium. The block is at rest. The block is at rest means you see that suppose this is a spring force. Restoring force is equal to kx. Restoring force is kx. The positive charge will repel to this positive charge is this direction means this is a force. What force? Electric force. Electric force. The charge is moving this direction means this is electrostatic force. This is equal to and restoring force is equal force. Equal force. Restoring force is formed in a spring. That is a restoring force. Both are equal. This block is rest position. The block is rest position means how many forces are acting on the block? This is a block, positive charge, mass m. This is an electrostatic force in this direction. This is a spring force. Spring force. Both are in opposite direction. Both are equal means F is equal to Fr means the block is rest. The block is rest position because that is a balancing force. Now Fe means intensity of electric field is equal. Intensity of electric field is equal to force by charge. F is equal to EQ. This is electrostatic force EQ. Now Fr means restoring force. Restoring force is equal to Kx. Kx. This is x naught means initial length of the spring. Initial length of the spring. Now x naught is equal to EQ by K. EQ by K. This is a block is rest position. Block is rest. Suppose block is in motion. Block is in motion. What is equal to of kx square? Of kx square. Do you know what this is of kx square? Of kx square means this is a electrostatic potential energy. Electrostatic potential energy stored in a spring. What is equal to force into displacement is equal to of kx square. X means extension of the spring. Extension of the spring. Now F means we know EQ. I'm writing EQ x is equal to 1 by 2 kx square. This x cancel each other. So this 2 take this side. 2 EQ by k. This is x. That is x. Now we will write that equation. X is equal to 2 EQ by k means now you can write this is what I'm going to write. This is initially 2 x naught is equal to EQ by k. EQ by k means x naught. I'm writing x naught. This is maximum extension of the spring. Maximum extension of the spring. Maximum extension of the spring is this value. So equilibrium means we can write this value. That is now we will see. Once again, I recall this one. This is a rod. This is spring. One end is connected to here, another end is connected to block. That block has mass m. That block has positive charge. Direction of electric field. This is find equilibrium and maximum extension of the spring. This is a equilibrium answer. This is a maximum extension of the spring. maximum extension of the spring, maximum extension of the spring. Now, when the electric field is switched on, so electric field is switched on. Now, this is a charge is moving this direction, restoring force is developing this direction. Now, basic points. Positive charge means direction of electric field and force both are same direction. Negative charge means direction of electric field and direction of force both are in opposite direction. Both are in a opposite direction. Now you will see this is a equilibrium situation. We call that is a equilibrium situation. This is a equilibrium. So equilibrium condition means F net is equal to 0. F net is equal to 0. So this is a restoring force. This restoring force in a spring. Restoring force pulls the block in this direction. This is an electrostatic force. Electrostatic force pulls the block in this direction. Both are in equal in opposite direction. Net force is 0. F is equal to Fr. Q is equal to Kx naught. X naught is equal to Q by K. This is equilibrium. Equilibrium answer. Next, maximum extension of the spring. Here W is equal to work is equal to. This block is moving from one place to another place means work done by the electric force. W is equal to half Kx square. Half Kx square means this is electrostatic potential energy stored in a electrostatic potential energy developed in a spring. That is work means force into displacement is equal to half Kx square. X cancel each other. X is equal to 2 EQ by K. This is X. X is equal to 2 EQ by K. EQ by K means nothing but X naught. X is equal to 2 X naught. Actually, initial length is, I'm taking this is X naught. Initial length is X naught. X naught. But how much it is expand? It is double expand by the electric field. Next talk. Okay. Next, calculation of so find intensity of electric field. Find density of electric field. Due to discrete charges. So find intensity of electric field. Find intensity of electric field due to discrete charges. Now, say electric field is equal to, so U1 plus U2 plus and small En. Because this is a superposition also. Principle of superposition. So now we will see the problem. This is a Q1. This is a Q2. This is a Q0. Distance between two charges is R1 R2. Now we will see these charts. So first of all, intensity of electric field is equal to due to point charge. Intensity of electric field due to point charge. Due to point charge. Point charge. Point charge. This is a Q. This is a P point. This is a test charge Q0. Distance between is R. This P point, we have to find out the electric field at the P point is equal K into Q by R square. This is a formula, very, very. K means 1 by 4 pi epsilon. 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 Now you will see K means 1 by 4 pi epsilon naught capital Q by R square. This is a electric field at P point. Electric field at P point. Now here, so we have to find out the resultant of electric field. Resultant of electric. Find resultant of electric field. Resultant of electric field. Resultant. Find resultant of intensity of electric field. Resultant of intensity of electric field due to discrete charges. Discrete charges. Now you will see. So first term, this is a Q1. This is a Q0. You take from R1. This is a you take P point, and dividing this part and close this part. You will see. Close up this part. Close this part means, but you are seeing this part. Now, say electric field at P point is equal to K into Q1 by R1 square. Your answer. This is a E1 line. But the direction of electric field is this is a positive charge. Direction of electric field is away from it. This is a E1. Now you can write direction of electric field is E1. This is our first one. Next, second part, this part you should take Q2, and this is a R2, this is a Q0, this is a P point you take, P point. So electric field, intensity of electric field at the P point due to the charge is E is equal to electric field is equal to K, Q2 by R2 square, Q2 by R2 square. This is electric field E2. Direction of electric field is positive charge is away from the charge. This is the direction of electric field. Direction of electric field. Now you can write it. This is E2. But you see, this is a line. This is a E1. This is a E2. E is a electric field. E is a electric field. Electric field. A resultant of electric field is equal to maybe U1 or E2. Resultant of electric field E2 greater than E1 answer. But you will see, we are calculating this one. We are calculating like this. Suppose in case distance between two or is suppose R1 less than R2, R1 less than R2, R1 less than R1 great means E1 less, E1 less. Now R1 greater than R2 means you can take this one. R1 less than R2 means R1 is less means E1 is greater. Now you can take this condition. Now ER is equal to E1 minus E2 when R1 less than R. R1 less than R. R1 less than R. Now resultant intensity of electric field is equal to E2 minus E1 when R1 greater than R. R1 greater than more E1 less. Now you are calculating like this. This is a Q1, this is a minus Q2. This is a Q naught from R1, R1. So find the intensity of it. Now this Q1 repel to discharge is this direction, that is U1. U1 is equal to K into Q1 by R1 square. Next, minus Q2 charge attract Q0 this direction, that is U2. U2 is equal to K into minus Q2 taken as positive charge. Now by R2 square. Minus Q2 is taken as positive. Minus Q is taken as positive charge. When we are calculate resulting force, minus Q is taken as a positive charge. Now we will see both in this line E1 and E2 both are same direction. Both are same direction means so resultant electric field is equal to E1 plus E2. U1 means K into Q1 by R1 square plus K into Q2 by R2 square. Now this is your resultant electric field. So now K means do you know very well 1 by 4 pi epsilon. 1 by 4 pi epsilon naught value. 1 by 4 pi epsilon naught. We'll see that. Okay now. So next problem is this is a problem number second model. This is a positive charge. This is also positive charge. Distance between two charges R and R. This is a Q naught. But what is the electric field? Now this is a positive charge. This positive charge repel this Q is this direction, that is the U1. This is a positive charge. This positive charge repel this is a Q naught in this direction, that is U2. Now U1 is equal at this point we have to calculate electric field due to the charge K into Q by R square. Next E2 is equal to. So at this point we have to calculate electric field due to the charge by distance is R square. Now resultant electric field is equal to U1 minus U2 or otherwise electric field U2 minus E1. So what is the U2 minus E1? K cube by R square minus K cube by R square. What happened? So resultant electric field at a P point is equal to 0. Resultant electric field is 0 at midpoint. Next one. Next one. Next one is this is a charge Q. This is a minus Q. This is a Q distance between R and R. Now we will see this is a charge repel to this is direction is U1. U1 means this is a point. At this point calculate electric field due to the charge is equal to K into Q by from here to reach the distance R square. Next E2. This is a negative charge. Negative charge attract discharges this direction, that is electric field E2. E2 is equal to. At this point we have to calculate electric field due to the charge. This is a K cube by R square. Both are in the same direction. Resultant electric field is E1, E2, both are same line. Both are in the same line means we are adding to the U1 plus E2. U1 plus. Both are adding electric field in this direction. Now next problem you will see. So what will happen in this situation? K cube by r square plus k cube by r square. Here both are same magnitude. Now we are calculating, that is so E1 is equal to E2 is equal to, that is equal to E. I am writing this is a E plus E. So what is answer? 2E. This is your resultant electric field at the P point. Now so ER is equal to E. E means electric field. That is K cube by R square. Your answer. Your answer. That is your answer. Now next problem is next problem. This is a Q1. This is a Q2. This is a P point. P point. And this is a P point. Here Q0. Here Q0. Distance between two charges is I'm taking from here to here is R1, from here to here is R. Now this is a Q1. This Q1 repel to the charge is this direction, that is E1. E1 is equal at this P point. We have to calculate the electric field due to the charge Q1 by distance between two charges R1. Next electric field. This is a Q2. Q2 also repel this Q0 is this direction, that is E2. At this point, we have to calculate the electric field due to the charge Q2 by R2 square. R2 square. Now both are resultant of electric field is both are in the same direction. U1 plus E2. U1 plus U2. Your answer. These two values put in this equation, you are getting resultant of electric field. Resultant of electric field. Now you are seeing to this one. Now next one. Now next problem, you are seeing this one. This is a Q1 charge, this is a Q2 charge. At this point is test charge at Q. This Q1 distance between two charges is A and B. This is A and B, distance between charges. This is origin point. Origin point. This Q1. This is a Q1. This is a Q. Q1 will repel to Q is downward direction, that is U1. Now U1 is equal to K into, at this point we have to calculate the electric field due to the charge. Distance between two charges is A square. Next, this is a Q2. This Q2 will repel to this Q0 is this direction. This is the direction, that is U2. Now U2, at this point, intensity of electric field, we have to calculate intensity of electric field at this point due to the charge K into Q2 by distance is B square. B square. Now you will see angle between this is angle between here is 90 degrees. Now resultant electric field is this is a ER, make an angle alpha. Make an angle alpha. Make an angle alpha. So tan alpha is equal to E1 by E2. This is your answer. Next, resultant ER is equal to root of E1 square plus E2 square. That is your answer. That is your answer. That is your answer. So next one. This is a Q1. This is a Q2. Distance between here to here is, this is a Q0. Q0 charge. Q0 charge. This Q1 is repelled to the charge is this direction. This is E1. E1 is equal to K into Q1 by distance is Y. This is Y. Next E2. This is a charge repelled to the charge is this direction, that is E2. E2 is equal to K into this is a Q2 by distance is X square. Now this is a resultant electric field. Make an angle alpha. Tan alpha is equal E1 by E2. E1 by ER is equal to resultant is equal to E1 square plus E2 square. Now tomorrow I will explain next concept. Okay, thank you.